And are we live? Oh, yes, we are. So, welcome to the part 2 of the stream. Today I'll welcome myself to while. Okay, one more time. So this is the part 2 of the. One more time. So, there we go. So this is the part 2 of the stream. Today we'll continue where we left off yesterday on Saturday, and that is going to be basically trying to get the. Am I streaming screen? Yes. To get the shooting to work properly, and then display health above our game. Maybe even add some kind of an end game condition, so we lose as a player. So if we go into scripts and we go into tower and we open the bullet script, I'll be adding some. Okay, actually, let's see. What was the game doing before? Wow, they're so slow. And the first one didn't. Weird. Okay, I see. So if we look at the bullet script, this for now can just go away. And this is what has to be changed. So what it did before, it was just setting the position of the bullet straight away to the target, and that was it. But what actually has to happen is the bullet has to fly. So what I'm going to do is I'll make a vector free. So first I'm going to try to get the direction in which we have to fly, and that is very easily done by taking the position of this against the target position. Like so. So this gives us the position or the vector free to the direction that we need. And of course our current direction is going to be transformed forward, so that's what we are currently facing. And I hope that's actually set properly. Now I'm going to make just a, and that's going to be our turning, and I'm just going to set to something like 60. And now that we have all of this set up, I believe all I have to do is use vector free. Okay. I know. So I'll make another vector free, and it's going to be the. So what this will do is vector free. Well, so what we're going to do now is we're going to rotate our object towards the. Towards our destination, like so. Yeah, of course. And that will, of course, apply at the turn that we had. Might have to be slightly higher. Maybe let's just, because we want it to be almost instantaneous anyway. And then let's just do time.delta time. What do we have? Float max magnitude. I'm just going to leave that as 1. That should work. And with all of that done, all we have to do is now apply our transform.rotation to look rotation, and then we use this variable here. And that hopefully should make everything move as intended. And let's have a go. Actually, let's increase the radius of the tower so we can test a little bit quicker. Come on, shoot, shoot. How big is radius of 10? Oh, it's that's right. Where is it? And I already saw a problem. Our bullets are not actually moving. Okay. Interesting. Let's get rid of this and try a different approach. So what we'll just do is, I guess the simplest way to do it is transform dot position is equal to vector free. Actually, let's create a vector free, and we're gonna call it our move direction, and we'll do the same thing we did last time. So this dot transform dot position minus target dot transform dot position, and we're getting our direction again. And what we'll do here is transform dot position is equal to vector free dot, or actually plus equal to move direction times, and we're just gonna set the bullet speed times time dot delta time. Code like that should be good enough. Let's give it a go. Okay, so the bullet is going in the exact opposite, and that's probably because of how the bullet is set up. So I'm just going to change this to a minus instead. There we go, like so. Now, as we see the bullets work, we kind of need to make it way faster than this. So bullet speed about 50. We don't want the bullets to be as visible. Oh, that's way too fast. 25. Why is it so fast? 10. And have you heard of a stream game? Oh, no, I have not. Oh, there we go. So now we have very simple attacking for the tower. Hello, hello. I don't play a lot of games besides like few multiplayer ones. Now the oh yeah, I have second screen for the chat. Yeah, yeah. This is a hobby of mine that I'm doing, and to practice my skills, I decided to make something from scratch without planning or anything. So this is a zero prep, just doing it as I'm thinking through. So what I hope to achieve is get better at doing this by using my already existing knowledge without doing any research, and then see how well I can think of code on the spot without having to look for tutorials and stuff like that. Okay, so what I'm gonna do now is I'll basically do, I guess, like a collision check. So there's two ways in which I can handle whenever the bullet glides with our enemy. So the first thing I could do is add a collision check here. So I could do something like this vector v.distance. So I could check the distance between the bullet and check the distance between bullet and the target. And if it's smaller than, let's just say 0.01, which is just a small unit, then we deal damage. And alternatively, I could do it by checking collisions, which is like this. So on trigger, enter, and then just copy that code in. So, but then we will of course have to check if our bullet is checking against an enemy. So if other dot game object is equal to target. So if our collision target is our target, then we will simply execute this code, which should remove health from our enemy, and then afterwards destroy this game object. So we'll try first and then second approach and see which one's better. Now the collision one at high speeds usually doesn't work as well. So if we give this a little play and really quickly just see if the enemy's taking damage. So the bullets do disappear, or do they not? Oh, that's right. Bullets don't have on trigger enter, and enemies probably don't have rigid bodies. So the enemies do have rigid bodies, but we don't have on trigger selected in the collider. And what we're doing here is we're on trigger entering through the code. So now, if we click on the first enemy, we're still not doing any damage. Let's have a quick look at the tower. Tower's damage is 10. Means that each. Let's see if we are colliding. Debug.log other. So we are properly colliding, but let's see if this if statement is being called. No. So the collision happens, but it's not target. And actually, I don't think it should be target in the first place. And that is because if it's target, well, if we miss the bullet, well, the bullet flies past our original target and it hits the next one, then that's going to be an issue. So what we will change here is we will actually tag our enemies. So if we go here, we go into tags, we click add tag, and we'll change this to enemy, like so. And we'll do if other.gameObject.tag is equal to enemy. And then what's going to happen is they'll lose health and they'll take damage and they'll destroy this game object, like so. The text collision for enemies to take damage, and we'll move this so actually we'll always destroy if we collide with another object. We'll always destroy this object. What we can do though is if other.gameObject is not nah, we can. So later, what we can do is we can change it to so that bullets don't collide with bullets, so that every bullet is under a same tag. And actually, we can just do it now. So I'll add a new tag and I'll call it bullet, because we don't want our own bullets to destroy each other when they collide with each other. So we'll do if other.gameObject.tag is not bullet, then we'll destroy this. Otherwise, it can just keep flying to wherever it's flying. And now we can attach the correct tag to our enemies and our bullets. And if we press play now, we will notice that no one's taking damage again. Why are we not? Oh, that's because I'm showing max health. I've been showing max health all this time instead of health. Where's our enemy health? We don't care about max health. We want to see current health. Like so. And there you go. So I bet they were taking damage all along. Okay. So now our enemies are slowly dying, which means that everything works fine. So let's just set the current health to max health, which is fine. Bullet. Class that handles bullet flight. Yeah, sounds about right. How fast the bullet travels. Now, what I'm gonna do now is make some changes to everything here. So firstly, we're gonna add the enemy health. So if we look at the enemy prefab and we go into prefabs, we drag out our enemy. So here we have our enemy prefab. Now, what we want to add is we want to add a canvas to our enemies by right-clicking on the enemy and going into UI and then putting a canvas with an image. Now, as we see, this canvas is quite big. We don't want it to be so big. We want it to be scale with screen size, and we want it to be in world space. And now we're just gonna make it much smaller. I'll make sure to add to reset it in the middle. And now we need to scale it all the way down. Let's disable the image for now, just so we can see the canvas. 0, 0. Like so. And now that we have our canvas, we can enable the image and just fit the canvas for the image, like so. So this is what it will currently look like. So let's keep scaling it a little bit. There we go, like so. And here we have our little health. Let's just reset the position one more time. Make it slightly above the head. Later on, we can add so that the health bars look always at the camera, so it's easier to see them. But for now, this is good enough. So what we will have is we will have our background, health background, and we'll also have a second one, which is the health foreground. Now, the important thing about the foreground is that it's gonna have to be a filled material. That means we have to attach something here. So I'm just quickly gonna go into paint and save just a little bar like this. It could be any size or shape. It actually doesn't matter. This is going to be the bar. And now if we go into desktop, and I find out my bar, I'm just going to drag it in here to the resources folder, and I'll create a new folder for this, and it's going to be called images, like so. Like so. Okay, now that we have this, we can program all of this in. So we previously made a image with a health bar. So what I can do now is go into enemy. Oh yeah, first we need to click on our new image. We need to change the texture type to sprite 2D and UI. Now that we have this, we can simply drag it here, and we have this new image type section that has become available. Now what I'll do is change this to filled, and that's basically how it's going to change. So let's just give it colors so we can see. So the health bar is going to be green, which doesn't stand out that much on the green background, and I'll just set this one to red. So as you see, the filled now goes backwards and forwards. So what we want to change is for it to be horizontal, like so. And there you go, it's the right way. So next I just need the code to move this based on the current and max health every time we take damage and once on the start. So I'll make a new function here and we're going to call it update UI. So what this will do is this will be ran first time when we start the object, so it changes the health to a correct value, and then one more time after we take any form of damage, which is, where is it? Like so, in here. Now, to to have access to this, we need to simply type in health bar dot fill amount, and that's going to be equal to, so it has to be a value between a 0 and a 1. So what we have here is max health, which is at 100. So what we'll do is we'll do current health divided by max health. Of course, this is not going to give us the value we want because it's not between 0 and 1. So I'm just going to encapsulate all of them in brackets and I'll just divide them by 100. Like so. And I believe that should be good enough. Let's give this a try. So now need to drag the health in, update the prefab, and let's see if that's going to work. Yep, it does. So there we go, we take damage. Show yourself. Why do you take an extra hit to die? So, and the reason why they were not disappearing instantly was because the code would only check if it's smaller than 0. So if it was 0, it would not count. So what it does now is if it's 0 and is equal to 0, so anything below 0 and 0 will be now removed properly from the health. So now we have both the health pool, the attacks for each of the type. Now, there we go. So now what we're going to do is add, I guess, a losing condition for the player. So I'll add health for the player, and then if they reach the end, that will minus from the health. So if we close all of that, I will now create a new canvas. I'm just going to change it to scale of screen so that regardless of what resolution we play on, everything will stay consistent. And we will call it the player UI canvas. Like so. And then here, I'm just going to put a text component at the top of the screen. Let's just resize this, make it best fit. And we'll put player health. And we'll just do 10 out of 10 for now. There we go. So so now we need to make a new script, and we'll just put it in. Actually, let's add it to our game manager, because our game manager will take care of whenever we're losing or winning a game, and there's already a static reference to this. So in here, I'm just going to make a new header, and we're going to type in player, just call it player, and we'll do int player health, and we'll also create a new text component. So we need to using Unity engine.ui to be able to access UI components, and we'll type in private text, and that's going to be the player health text, like so. Now we'll just default this to 10 for now by default, so it works. And now that we have added this, we can click on our game manager and we can drag in the text components. So player text, player health, like so, and we just drag it in. Okay, so here we'll make a new update function, but this time it's going to be public. So this will be public update player health. Now, of type void. Now, what will this do is this will update player health when an enemy reaches the end of the map, the path, like so. And what will basically happen is we will simply put just -1 from our player health. So we'll just do player health minus, like so. We'll then also do if player health is smaller than or equal to 0, then we'll just make it equal to 0. And we'll also do game over here. We currently don't have anything, so for now we'll just create a private void game over. And we'll just do debug.log game has been lost, like so. That's all it's going to do for now. And we'll just call game over in here. And finally, we will update the text. So we'll do player health text, and that's going to be player. What did we write at the top? We're just going to copy this over here. However, instead of typing 10 out of 10, we'll do plus player health. And then actually, let's make a maximum value here as well. So we'll do player max health. Instead, we're going to make that equal to 10. And then in start, we'll make player health equal to player max health, like so. And then we'll do player plus. And then player max health, like so. I'm just going to put this in a separate function for now. Actually, let's just leave it. There's no point. So I'm just going to copy this over and put it in start once we set the health. So everything, so the text says what it should, which is essentially what the setup one was anyway. And now, if we go into our enemy pathing, which is here, in the enemy movement, now, where do we have it? So before we destroy the object here, at the end of the path, all we have to do is, where are we? We'll just do game manager dot instance dot, what was that function called? Update player health. And this will minus health from our player every time we do this. And when it reaches 0, it will say game over. Come on, guys. Single tower is actually doing quite well. Okay, there you go. So health is decreasing as it should. Now, let's just remove damage from the tower for the sake of testing and increase the speed at which the enemies move. Just so we can see the message for the end of the game. And if you look, yeah, debug works as expected. So that's fine. Now I have 20 more minutes for the stream. So what can I add? Let's think. We can make scriptable stats for everything and prepare towers to be placed. Same for the enemies. So what I'm going to do is I'm going to slightly change this current system to use scriptable objects. That will allow us to create a lot of new towers and enemies really quickly with various stats. So here I'll create a new class, a folder. I'll call it Scriptable Objects. Also in our assets folder, I'll create a Scriptable Object folder. Now, if I'm going back into scripts, I'll create two sets of scripts. I'll call it let's just call it, we already have a class called tower, so we'll call it base tower, and we'll call this base enemy. Now, scriptable objects are simple data containers, but they're very useful to work with, especially for things like items for RPGs, even for Switch-based AIs. So to create the scriptable objects, we firstly change this to a scriptable object, and we create an asset menu, and there you go. So the properties are the file name, menu name, and order. You don't need to have any of them. They are all optional fields. So order is in which order they appear, because when you have more, some can be lower, some can be higher in the menu. So the file name for this is going to be a new enemy, I guess. And the menu name is going to be, I guess, enemies, new enemy, like so. Or can we just leave it like that? Let's just give it a quick. So this is how they work, more or less. Now you right click, you go into create, and you have enemies. There you go. Yep, so I was right. A new enemy, like so. So if you go here, we have now new tab, enemy, and if you click here, it gives it the new enemy name which we gave it, and that's our scriptable object done. So what we'll do is quickly add the same to base tower. However, of course, towers will be in their own one, so it's going to be new tower, like so. And then, so every enemy will have a health. They can have different health based on what kind of an enemy they are. They will have their own speed value. So health, speed, what else do enemies have? I guess that's it for now. And the tower will have damage. Tower will have, actually, how is tower? Is it a float or an integer? Float. Let's keep it a float then. So we'll have damage. We will have bullet speed. We will have different types of bullets based on the tower. So we'll type public, or actually we can pre-assign the bullets into the tower anyway, so that doesn't matter. What could their towers also have? They will have their own range. and they'll have costs to be able to buy them. So this is, let's just call it a buyout cost, and then we'll create a sellout cost. We'll make them integers rather than floats for player currency to be just a static value. So the damage that the tower does, speed in actually bullet speed will be, yeah, we don't need to have that for now, or the range that the tower has. The y out cost to place the tower, the sell cost to sell the existing tower, and we also have some images here, because when we click on the tower we probably want to have some kind of an image to show what the tower looks like. So we'll have public image tower icon, like so. Sprite, it's a type sprite. Image is a component. So the image of the tower. We'll actually have a sprite for an enemy, so you can click on an enemy to see his stats. So we'll have enemy icon, image of the enemy, how fast the enemy moves, and then how much of the enemy has left. Now that we have the following variables, we can then assign those scriptables to each prefab, and then every time the game loads, we will have that set to it. So first, let's create two folders, one for enemies, one for enemy, one for towers, like so. And we'll just assign new tower. So we'll call it the basic tower. And we'll call it for the enemy, we'll just call it a basic trooper. Now, what we can do here is change the stats to whatever we want, which is basically what we had last time, like so. And we can start changing the system a little bit so it uses this. So if we go into tower, we'll just do the tower for now. We'll later work on the enemies because I don't have that much time left. So we'll do, and then we'll do base tower, new, oh, tower stats. And now, rather than the tower having its own predefined values like so, we will only have them be assigned for the use of our base tower. So the damage of our tower will be equal to the base stats, and then later on we can expand this so we can level up this, but that's good enough for now. So let's just move these guys out. And what we would essentially do is at the start, well, on awake, so when our tower gets, or actually on enable, so when this tower becomes active, what we'll do is we'll use, so we'll set the damage equal to tower stats.damage, and range is going to be equal to tower stats.range, like so. So this might look like it's unnecessary, but if you have a larger game, it'll be very neat to do it this way. Okay, moving on. I guess, what, 10 minutes left. What can I do in 10 minutes? So I'll just quickly add some small features, like pausing real quickly, so we can stop the game. And let's just go here. Let's make a new folder. I'll call this the game management. There we go. Since we already have canvas, we can now add a way to stop the game from progressing, and I'll add a simple panel. Scale it slightly. Like so. Come on, center yourself. Come on. Oh. And add some buttons, so this will be resume, and the other one will be quit. There we go. Like so, and this is going to be the pause panel. Oh. Okay. Like so. Let's just make it so it automatically expands, and I'll just add a vertical layer group. So what layer group it does is it just moves it, and we'll just keep it center like so. Now that this is done, we can attach our pause script to our canvas. Now the reason why we will attach it here, not to the panel, is because this panel will be disabled like so on and off. So I'll create a serializable field private form, and that's going to be the pause menu or panel. Now on start, we'll set it to false. So we'll do GameObject.setActive false, and then we'll have a simple update function which will either set it on or off. So if, and then pause panel dot GameObject.active in the hierarchy. So this checks if it's active. So if it is active in the hierarchy, then that means that the game is paused. And then otherwise, it means that, so this means that game is currently paused, and that will mean that the game is not paused currently. So to actually pause the game, we use this thing called time dot timescale, and pausing the game sets it to 0, whereas if it's playing, it sets it to 1. Now you have to be careful about using timescale because what timescale actually does, it stops time for anything that uses the physics in the first place. So if we go into a bullet, the position gets changed, and it uses time.delta time to move. So that means that our bullets will freeze in space. But if we were to move our bullet using, for example, invoke repeating, with the invoke repeating function, that would not stop it. That would constantly move because invoking does not run for the physics. So we run this, and oh yeah. So if input.getKey down and then key code P, so we'll use P. So if we press P, we perform this check. So if it's paused already, then we set it to 0, and then we disable the panel. And then we do the exact opposite in the other one. So if it's not and the P was pressed, we set it to true. and those pausing when the P button is selected, like so. And of course, we also want to have an option to leave the game for this, so we'll do public void quit game, and for that we'll just type application dot quit, like so. This will instantly quit the game, so there is no like a little screen that appears and tells you to quit. It just automatically will turn off the application, so quits the game. So this is something that could be revised later to prompt the player first if they really want to quit or not, and maybe save the game if the game has a save feature. And of course, resume is also a button. So what we'll do is public void resume, like so. However, resume, so all that resume does is basically does this. So we'll just remove that from here and type in resume instead, like so. And then resumes the game. That's because we can either press P again to resume, or we can click on the button itself. Now, to assign, we just drag in our canvas for each button, and then here we look for the pause menu, quick game, and we do the same for the bottom, but with resume function instead. And now if we press play, it should work. Oh yeah, that's right. So what we didn't do is we didn't select the pause panel, and that created an error. There you go. So, oh, interesting. Let's clear out the error first. We actually have a new error, which is, so we actually didn't assign our base tower to our tower, which created a small error. I messed up the order, didn't I? Where is the little menu? Okay, you know what? Let's leave it for now. I don't have time to look at it anyway. Okay, so let's just double check that everything works. Yep, the shooting works, the health works, and I believe this is a good point to stop. In the next part, I'll fix the pause bug from today, and I'll actually make the towers be placeable. So there's going to be costs added that you'll have to pay for, and the towers themselves will be placeable on any of the green blocks on the map. Now, as there was in the first part, I actually have 3 different types of colors on each tile. So there is there we go, you have the grass block, which is the default one, and we also have the dirt blocks. So the dirt blocks are going to be the blocks you're not allowed to build on, but the grass blocks will be the ones you can build on. Yeah, so that'll be it. I'll be probably streaming this for another hour tomorrow in the morning before work, if someone's interested. Thanks for watching.